Hello Year 5, I hope you are all well today. We are going to start our new science topic this term, which is Earth and space. Now this is a really exciting topic to be doing this term, really exciting topic. So we're going to be doing this topic over the next part of the term. So for today's first lesson, we are going to start by looking at the sun, the earth and the moon. Okay, so before we move on and do anything, what I would like you to do is I would like you to have a sit and think about what you already know about the sun, the earth and the moon. Now, we have done mind maps in lessons before. So what I want you to do is you can either do it as a mind map, you can do it as a list of bullet points, or you can do it as subheadings under each of the planets. Entirely up to you. But I would like to just jot down some ideas or anything that you can remember or anything you know about the sun, the earth and the moon before we move on. So have a pause of the video and just jot down some ideas. Okay, so here are some ideas that might be able to help you with your list if your list is looking a little bit small. So do you know any of the scientific meanings of any of the words that are on the screen? And would you know how to apply them to our science topic? So the easy ones you'll probably know will be the sun, the moon, and stars. We know what stars are. We know what nighttime is. Would you be able to tell me if you knew exactly what a planet was? You might be able to know about axes because we have actually looked at this in geography before and some of the same rules would apply. I know we've looked at eclipse before, so you might remember what eclipse is. You should know spherical. I mean, that's one of our mathematical terms. Obviously, we've not covered shape yet this year. Orbit's a very important one, and rotation and rotate is a very important one when we talk about the planets and our solar system. So if you think that your list is looking a little bit small and you think you might need to add to your list with some of these ideas, pause the video and go back and see if you can add anything to your list that's going to make it seem more useful to you. So we are going to be focusing on specifically these three celestial bodies. Now you may be thinking to yourself, what on earth, no pun intended, is a celestial body? Okay, so celestial is what is known as an adjective, and we all know that adjectives, yes, are describing words. Well done, Year 5. So a celestial body is something that relates to the sky or something that is in outer space. And obviously a body is a mass or a unit of something. So the Earth is a body of Earth. It's a planet and it's a celestial body because it's outside within outer space or it's in the sky. Okay. So we are going to concentrate more on looking at those today. So don't worry about the partnered work. That's obviously something that you're not going to be able to do at home, unfortunately, but I've given you a little bit of an idea now of what a celestial body is. So let's explore them a little bit further then, shall we? So everyone knows what the sun is. You see it every day. It's in the sky. It's big. It's very hot. Okay. And it is at the centre of our solar system. Now, you may not 100% know what a solar system is. Okay. What I want you to do is pause the video and have a think. What is a solar system? And come back and I'll explain and give you a definition. So a solar system consists of the sun and anything that orbits the sun. So when we orbit something, orbit is when we move around it. Okay, that's when gravity moves a planet or a body around another one. So this will include all of the 8 planets within our solar system. There is a good acronym to be able to remember how to say the planets in order. We'll see if anyone can come up with any of their own over this unit. Includes all of the individual moons. So we have one moon, but there are other planets that have more than one moon that rotates and orbits around that planet. You've got dwarf planets like poor little Pluto sitting at the end, kicked off the main planet list. You've also got asteroids, which are large lumps of rock and dust and space material. We've got other small planets, also sometimes icy objects that might be in space. Believe it or not, space ice is a real thing, a very dangerous thing if you're up on the International Space Station as well. But all of those things are what build up that empty space within our solar system. Believe it or not, there's more than one set of solar systems that's in our entire universe. That's moving on to galaxies and bigger things, but I won't blow your minds just too much at the moment. So the sun is actually a star. Okay, so the star is made up of burning gases. Now we looked a little bit about gases last term. So these burning gases is what covers the surface of the planet, and it can burn up to over 5,000 degrees Celsius. Okay, so you imagine when our planet's at 40 degrees and we're thinking, wow, that's really, really hot. That heat's coming from the sun. which is 149.6 million kilometers away from Earth. Okay, so if we think 40 degrees is hot, it's going to be nowhere near as hot if you try to get a lot closer to the sun. Now, obviously, that heat is what provides our solar system with the light and the warmth. Okay, so we have the light during the day, but also we have the warmth from it as well. Now, that light, okay, has to travel. Now, we'll look at traveling from light and sound when we do this in another unit. But the light from the sun only takes around 8 minutes to actually then travel that distance, that 149.6 million kilometers, to then get to Earth. So that is a long way for it to travel. And considering the distance that it's got to travel, that light doesn't really take very long to get here. Same thing applies though for the warmth as well. Now, the sun is the biggest object in our solar system. Now, if you have a look at this picture over here, this is not to scale. And it's a real shame that we're not in school, because we would have been able to build some of these models to be able to show you. And even during maths, we've been able to measure out some form of units to show how far away they are from each other. But that little teeny tiny dot there, that is us, that is Earth. And that big thing behind it, that's the sun. So in comparison, we are minute. We are not the smallest planet in our solar system, but we are one of the smallest, okay? So it makes up 98% of the total mass of our solar system, the sun does. So if you add all the other 8 planets together, that mass combined is only 2% in comparison to the sun within our solar system. That's pretty big. Now, the sun is roughly spherical. Now, we know that spherical, if we take the root word spheric as sphere, we know that a sphere is a 3D round object, okay? Now, to say it's roughly spherical, obviously on the surface of the sun will be various different grounds and terrains and heights and levels. So it's roughly shaped in a spherical shape, so in a ball. And it is about 1,400,000 kilometers in diameter. Now, to be able to compare that to you, I don't have anything to compare it to because nothing is that big, but it's pretty big. We know that diameter as well goes from one side to the other, okay? So you have the radius, which would be from the middle to the outside, but the diameter would be to go from one point, almost like north to south pole of the sun. So that would be the diameter all the way around. Now, I can give you a comparison. This means that the sun would be able to fit 1,300,000 of us. So if you were to have the world and you were to replicate it 1.3 million times, you'd be able to fit that into the mass of the sun. Yeah, pretty scary. Pretty scary at how big the sun actually is. Now, Earth, our home planet. Earth is actually a planet. It's not a star, just like the sun. Now, it's the 3rd planet from the sun. Okay, hence why we don't have as hot a temperatures as Mars and Venus do, which are the 2 closest ones. And the only one which is the correct conditions to actually sustain human life at the moment. So we are the only planet that has been able to have human life on it. So Earth is also roughly spherical as well. Now, obviously, we say roughly because we know that we've got planets and we've got moons and we've got stars. None of them are perfect. Obviously, we know if we look close to the moon, you've got craters on the moon. It's not perfectly smooth. We have mountains, we have volcanoes, we have depths that go below sea level. It's not spherical, okay? Now, a planet is the celestial body which orbits around a star. So obviously we orbit on an axis and we go round the sun, okay? So we spin on our 24-hour axis with our moon, but within 365 days of the year, we also go round the sun as well. Now, the moon, okay? Now, the moon is very clever, okay? Now, it's a very special celestial planet because it's actually a natural satellite, okay? So, because it's a naturally occurring object within space, within our solar system, it's not something that's man-made, and it orbits our planet. So it has its own gravitational pull. Don't worry, we'll cover this in another lesson, that allows it to move around, which obviously then pinpoints our satellites for day and night, okay? So the moon orbits the Earth, but the moon itself doesn't have anything orbiting it, so that's the only job for it to do is to go around the moon within the 24 hours. Now, just like all the other ones we've discussed, the moon, again, is roughly spherical, and it's about 1/4 of the size of the Earth. However, there are times where you might look at the sky and actually see that the moon on some days looks a lot bigger than the sun does, but sometimes that's just due to how close it is to the Earth. Obviously, the size of it doesn't change.